We want to choose machine learning in our solution, but we are not quite sure which hardware or software option to choose and which options exist in the first place. So if we are talking about hardware for machine learning, the first thing we should discuss is whether we will use the local hardware or cloud services. The local hardware is the hardware we have at our premises in our local system. And the first big bonus of this option is that we don't need to leave our internal environment. Everything we have ourselves and we control it completely. It also doesn't depend on the connectivity or functioning or any other system. It is completely independent and we can always count on it that it will work, or we are there and we can fix it whatever problem arises. Disadvantage of this approach is definitely the possible need for some expensive equipment, expensive processing units that we might need depending on the complexity of the model that we are using. And these processing units evolve very fast and might also become obsolete soon, and we might have to upgrade it and buy some more equipment and so on. On the other hand, if we discuss the cloud services as an option, they are basically inverse. So there is no need to buy expensive equipment. We always have access to the most recent hardware upon request. So we go to the cloud service, we request, we want to train a model, we need that and that and that hardware. We can pay for that and use its processing power as a service. The disadvantage of this approach, one that is a lot talked about, is the need to leave the internal environment that maybe we don't want to do. We want to have everything in our local system and we don't want to depend on some external services or environments. The next thing we might discuss is, do we use the open machine learning frameworks or some proprietary solutions? Open machine learning frameworks are free to use, and that is definitely one of their biggest advantages. But they require probably more knowledge and skills, more coding, programming, more hands-on coding that we need to perform ourselves. A good thing about the open machine learning frameworks is that we can always follow the trends that exist in the machine learning community, and we can also apply ourselves some models or change, adjust models so that they fit completely the need that our system has. On the other hand, the proprietary solutions, they can give us some out-of-the-box solution for different models, but they definitely come for a price. So if we want to choose this option, we will probably be able to develop our model faster because there is the out-of-the-box solution that we can use, but it all definitely comes for a price. Then we have some more aspects that we need to consider when choosing these hardware and software options that are very, very closely related to the options that we choose. And one of those is definitely the data privacy. It is something that is very much talked about today in both the scientific and the business community. We value our data highly and we don't want to expose it or have any risks on the data privacy from our system. This can affect both the option between the local hardware or the cloud and the open framework or the proprietary solution, because often because of the data privacy, we want to have our system closed locally and not let any of our data leave the system, no matter how secure the connection is and so on. Another very important topic that is also related to the hardware and software options that we are choosing is explainability of our machine learning model. Explainability means, are we able to explain what our model did or not? So do we know why our model made a certain decision or prediction, or how it reached its output, or we don't know. So this is also very important when choosing the model, the exact model that we're going to use, and whether we will program this solution from scratch or we will use it, for example, as a cloud service or a proprietary solution. And sometimes we are able, it depends on the problem that we are solving. Sometimes we are able to use a model like a black box. We give it inputs, it gives us output, and the outputs are good, the error rate is very small, and we are happy with that. But for some situations, the risk is just too high, and we have to be able, for insurance reasons or whatever other reasons, to be able to explain why our model made this decision or why it predicted this and that and made us decide that we will take one path or the other. So this is also something to consider when starting with your machine learning journey and discussing what hardware, what software, and what exact model are you going to use for your solution.